Okay, so my name is Raymond Morgan, and I'm a professional engineer. And so a little background for those that are not don't know who I am. You know, I've worked in both the private and the public sector. I worked for about 25 and a half years with Pima County Wastewater. Most of that time I was an engineering manager. Then I retired, and then about a year later I went to work with the Arizona Department of Environmental Quality as a compliance officer, professional engineer, and so on, doing inspections, reviewing design plans, and so on. And so I retired, and I was off for about 3 months. And then I came back to work for ADQ as a contractor to do training and to be a subject matter expert. And so today we're going to take a look at septic system maintenance and operation. So, well, before I do that, I want to mention that as I go through this, please just list any questions you have, and then we're just going to go ahead and look at the questions at the end of the presentation and try to address those. So let's look at first, we're going to look at some of the topics that we're going to go over here. First, we're going to cover the topic of inspection, what you should be looking for and how to do the inspection. We're going to be looking at the maintenance needs of the septic system. We're going to be considering the responsibilities of the service provider and when you should get a service provider. We're going to consider water use efficiency and the impact that has on the septic system. We're going to look at also proper waste disposal and look at what you shouldn't be putting down the toilet, and also where there are appropriate disposal places for that other items are. We're going to consider drain field maintenance, just like there is maintenance needed for your septic tank. There's also associated maintenance for the drain field too. Of course, we're going to look at the septic system overall maintenance, and then we'll have some pictures of some different septic systems, in particular disposal areas in many cases, and look at what is there in that picture and maybe some lessons we could learn from it. So first, let's just look at the basic gravity septic system. And as we see here, we have, of course, you got your clean out, going to your septic tank, and going to your distribution box, and then going out to the gravity field. So that's your basic elements of the septic system. But let's add a little more detail now. So we got the wall of the house, and then the whole area outside the house where you got the septic tank and disposal field. So we see here the clean out, that's usually about a couple of feet off from the foundation wall there. Then we see the septic tank, and then the septic tank riser lids. In Arizona, you're allowed up to a maximum of 6 inches of cover over the top of the riser lid. I personally recommend bringing it all the way to ground surface. And the upcoming rules, we're going to make that a requirement. And then the inspector here is holding a clipboard with the as-built drawings, also known as the record drawings, to help them properly locate the septic tank and disposal field. And then we have some drain field inspection ports. Hopefully your system has that. I recommend those. It helps you to be able to evaluate what's going on a little bit better in your disposal field. If you do have those, you can remove the cap and take a mirror and then shine sunlight down in there. You could use a flashlight if need be, but if you have the ability to shine sunlight down into them, you'll get much better illumination than if just with a flashlight. Okay, now let's consider what residential wastewater is. Typically, residential influent wastewater strength ranges, the 5-day BOD ranges from 100 to 300 milligrams per liter, and that's per NSF 40. And total suspended solids is 100 to 350 milligrams per liter per NSF 40. Now that strength is going to vary some, and we'll get into some reasons later why that does vary. Now, Arizona Administrative Code says that this raw wastewater that goes into the septic tank is supposed to exit there with a minimum effluent quality with a 5-day BOD of 125 milligrams per liter, and your total suspended solids 75 milligrams per liter. And that's what should be shown or coming out. Now, when we look at the inspection of the septic system, there's some factors that are going to influence the maintenance needs of it and how much maintenance is required. First of all, we're going to note the number of people using the septic tank is going to influence the maintenance needs of that system. Basically, more people, there's a greater chance of either hydraulic or organic overload. And notice that hydraulic is referring to the volume of wastewater going into your septic system. Organic load refers to the solids loading that's going in there. Another factor that can influence your maintenance needs is the volume of the daily wastewater discharge. So that's going to affect the functionality of the disposal field. In particular, it's also going to affect the septic tank and the treatment process, and I'll explain that in a little bit. The other factor is the organic loading of the septic tank. And if you're putting wastewater that's very high in BOD or suspended solids, that's going to put a little more load on the septic tank. And as a general guideline, you can figure that 0.17 pounds of 5-day BOD is the loading per day for one person. So as you can see why you get more people in the house discharging wastewater, your organic loading is going to increase. And that, of course, is going to affect the treatment process. That just means there's more solids for the septic tank to settle out. And then the final factor is the size of the septic tank. And this is going to affect whether solids and scum are trapped in the tank or carried out into the disposal field. Now in Arizona, our requirement is 2.1 days of detention time in the septic tank. Now, the size of the septic tank is not only related to the organic loading of the septic tank, it's also related to the volume of the daily discharge. Because if you have a large volume of wastewater going into the septic tank, and especially if the septic tank is undersized, you will not get a 2.1 day detention time. You will get something less than that. And the less detention time you have in the septic tank, the less time it is for solids to settle out and hopefully settle out, and you're trying to avoid those solids being carried over to the disposal field. So if you have an undersized septic tank or a higher volume of wastewater going into the septic tank than it was ever designed to handle, you can have solids going into your disposal field and adversely affecting it. Now let's consider some other factors that influence the maintenance needs besides the ones we just looked at. We also need to look at the depth of sludge and the depth of scum in the septic tank. An excessive depth of sludge or scum can allow these solids to get carried over into the disposal field and ultimately shorten the service life of that field. Another factor that's going to influence maintenance needs is if you have electrical and mechanical pumping components. In many cases, those are subject to wear and tear or corrosion or whatever. So if you have an electrical panel or pump control panel and water is leaking into it, well, things can corrode and cause failures. So Also note components have a given service life, and they're going to be need to be replaced at some point. Now, in order to do our inspection, we're going to have to measure the scum thickness as well as the sludge thickness. So I'm going to explain how to do that and how to construct a tool to enable you to do that measurement. So we need a little bit of materials here. We need one piece of PVC pipe, 10 feet long. It could be like 1/2 inch, 3/4, or 1 inch diameter. We need one elbow joint. We need 2 end caps. We need some PVC cement. So what we're going to do, we're going to cut a 6-foot section off of that 10-foot section of PVC with a saw pipe cutter. And then the remaining 4-foot section, we're going to cut a 6-inch piece off of that. And then we're going to use the elbow joint to connect that 6-foot and that 6-inch section, and we're going to secure it with PVC cement. And then we're going to install some end caps using the PVC cement because we don't want the sludge and the scum getting inside the PVC pipe. So we now have a device to measure the scum. Now we got to make a device to measure the sludge. So in that we need another 10-foot piece of PVC pipe. This time we need a threaded coupler. We need 2 end caps, PVC pipe, and we need 3 feet of white self-adhesive Velcro tape. So we're going to cut the PVC pipe in half. We're going to create 2 5-foot sections. Then we're going to install one end of the threaded coupler on the end of each 5-foot section of pipe, and we're going to secure them with PVC cement. Then we're going to install the caps on the other ends to make sure sludge and scum doesn't get into them. Then we're going to separate the Velcro tape, and we're going to discard the rough or tooth side. We're going to remove the plastic backing from the soft or loop side of the Velcro tape and apply that Velcro tape from the bottom of the end cap up the stick until it's all adhered. And so we'll have our 3 foot of Velcro tape there. Now, when the cement is dry, then we're going to connect the 2 5-foot sections together with a threaded coupler. And we're also, I want to note that after you use it, we're going to explain how to use it. You clean it, and then the stick can be unscrewed for easier storage. So let's look at a septic inspection safety guidelines. And we got 4 F's: friend, fumes, falling, and infection. Infection, the F is letter that's third letter in. So first of all, in regard to the friend of the inspector, you always inspect with another person present for safety, assistance, and to aid with the checklist. So in this case, one person is got the clipboard and is going through the checklist, and the other one is removing screws out of the riser cover. Second, fumes. You need to keep your head outside of tanks. The fumes from septic tanks are toxic and can overwhelm you. Hydrogen sulfide is especially dangerous. You can smell it, and if it's strong enough, then it will paralyze your olfactory nerve so you'll no longer smell it. And you could put yourself in harm's way. Generally, as long as you keep your head out of the septic tank, other than some bad odors and stuff, maybe some eye irritation or something, you shouldn't have any problems. Okay, let's consider the safety one of falling. You don't want to fall inside an opening. So you want to keep septic tank openings in front of you. Falls may occur when people step backward into an open tank. Therefore, never leave an open tank unattended, and preferably maybe put a lid over the one that you're open and that you're not using, and only have one of the access openings at a time that's open. And then fourth, infection. And of course you have gloves on, safety eye gear. So avoid touching your face with your glove after the gloves have particularly been in contact with raw sewage because it contains viruses and bacteria. You don't want to transfer them to your face. You should also wear protective clothing along with the gloves and eyewear at all times. And you're going to clean your tools and clothing with bleach at the end, and we'll explain how that procedure is done. Now, let's just look at your common septic tank. It does not exactly represent Arizona's version of a septic tank, and I'll point out the minor differences. So, first of all, we see we got the inlet over here, and we have the outlet here. And so the outlet invert is lower, needless to say, than the inlet. I have went to places where they've reversed them, and you can't do that in the field without bad consequences. So then you have the inlet baffle, also known as the inlet sanitary tee. We see the scum layer up here, and we see the sludge layer at the bottom of the tank. And then we see a center wall or baffle here. And this, in Arizona, we have a hole through the center wall and lined up with a clear zone. In this particular tank, they use a sanitary tee to carry it through from one chamber to the other. And then we have the outlet sanitary tee here with a filter that fits in there. And of course, you have the riser with the covers. Now, depending on the age of the tank, some will have plastic baffles and others will have concrete baffles. So let's review some procedures associated with opening your septic tank. And of course, on our checklist here, we've got our safety equipment. We've got another person here with us, so we're not doing this alone. We're going to clear away dirt and debris from the access riser lid. Now, some tanks do not have risers. In that case, you may have to dig down to the top of the concrete tank and remove the lid there. And just as an aside, I can tell you sometimes the concrete lid will fuse to the top of the concrete tank. And that's why I have found that it's helpful if you put some clear, thin plastic, well, thin clear plastic under the edge of the riser, under the edge of the tank lid or cover access opening, so that you avoid that concrete fusing from taking place. So you're going to remove the riser and the riser lid, which is the green plastic one here. Then it shows the two people lifting this concrete cover out off of the tank. I personally do not recommend the need for two lids, but in this case they do have it, and that would be interesting to get out, especially if it's tended to fuse to the top of the septic tank. So anyway, you're going to carefully remove it, and you need to be very careful and use proper lifting techniques because it can be very heavy, and you can strain your back, and as they note, it may require prying, and I've found sometimes that alone doesn't do it. Then we're watching out for open lids behind us so that we don't back and step into it and drop into the septic tank. And as we noted before, you don't want to leave it unattended. Now, this is a key point. You want to check the risers for water tightness. And one method of doing that is watering around it and seeing if water starts appearing through the joints in the riser. And this procedure that I'm citing from here was actually developed by the state of Washington. The state of Washington requires the septic tanks be inspected on a regular basis. I believe it's once a year. But they allow the homeowners, after some education and going through a video course, to do the inspection themselves. But they have some warnings on here that if it's bad, then you need to go ahead and get somebody like a professional in there. So, and if you answer no, then if you answer no to any of these questions, stop your inspection and contact a professional. And as noted, if your tank has two chambers, perform all steps on both the inlet and outlet sides of the tank. Okay, and just to note, I'm not able to see any chat bot messages or anything else. All right, next we need to measure the scum layer. So as a reminder, the safety check here is you're going to keep your head out of the riser in the tank. So you're going to insert the scum stick. You're going to place it on top of the scum layer. You're going to mark the scum stick even with the top of the riser because you're trying to get a reference point to the top of the scum layer, and then you're going to shove it through it. So you're going to mark the scum stick even with the top of the riser. Then you're going to make a hole in the scum layer and lower the scum stick through the hole. Then you're going to pull the scum stick up until you feel the resistance of the scum layer. You may need to rotate the scum stick 90 degrees so you don't pull it up through the hole, but you encounter solidly the scum. Then you're going to mark it again. What you've done, you've now located the two, you're basically defined what the thickness of the scum is by measuring the distance between the two marks that you see here. And if the scum layer is more than 6 inches, have your tank pump. And I'm going to later have a slide that talks about what thickness is for scum and sludge and when you should pump and who says when you should do it and so on. Okay, next you're going to need to measure the sludge layer. So you're going to carefully insert the sludge stick into a hole in the scum or through your sanitary tee or baffle right here. You're going to lower the sludge stick to the bottom of the tank and wait 3 minutes. What you're doing, you're wanting the sludge to stain and darken that Velcro layer on your sludge stick. And then you're going to remove the sludge stick, and then you're going to measure the length of that sludge stain on the Velcro, and that's going to tell you what your sludge thickness is. And so the action is going to be potentially pump the tank when the scum depth is greater than 6 inches, or the sludge depth is greater than 12 inches, or the total depth is greater than 18 inches. Okay. Now we got to go to that baffle filter. So you're going to go to the outlet filter and the outlet baffle, and you need to remember that not all systems, first of all, have filters. And if you don't have one, we recommend you get one. And so you can ask for help in that area as needed. And so when you secure the end of the outlet filter, pull it up halfway and then stop. Let it sit, looks like for 15 minutes. And so this is going to allow, first of all, any backed up effluent. If you've got a partially clogged field, it will allow that effluent to flow back into the tank. And it will also allow loose solids from exiting the tank and damaging your drain fields. So if there's like a lot of solids on, loose solids on your baffle filter, you kind of let that stabilize a little bit because you're going to rinse it off, but you're going to rinse it off in a way that falls in the tank and not going down the baffle and out to the field. Okay, and you're also going to let the effluent kind of drain out of that baffle completely. So when the effluent is settled, then remove the filter completely. And note, as a safety check, avoid splashing and contact with sewage while rinsing the filters. So you want to make sure that the sprayer or hose you're using isn't coming out, the water isn't coming out so hard, it's going to hit the filter and splatter sludge and solids all over your face and clothes and so on. So you want to use that with just a little care. Now, consider what type of effluent filter you've got, or septic tank effluent filter. If you have a yellow tough tight filter, fill a bucket with water and dip the filter into the bucket. Then turn over and rinse. carefully pour out the bucket into the inlet side of the tank. If you have a sock filter, turn it upside down and rinse it gently with a hose over the inlet side of the septic tank. Replace the filter into the outlet baffle. If replacing a tough tight filter, make sure the arrow points toward the drain field. Then replace and secure the lids. Now we move from the septic tank, we're going to go to the drain field. So you're going to walk across the entire drain field, checking for odors and damp areas. Are there any strong odors? And this is where it goes. If it's yes, you need to call a service tech. Are there any mushy or swampy areas or surfacing effluent? If it's yes, call for the service tech. That mushy, swampy areas indicates your system has failed, and what you're walking on is effluent loaded with virus and bacteria. Next, you find your inspection cap ports. Open and look inside each inspection port. You may need a flashlight. I think you will need a flashlight, or else you need a mirror that can reflect sunlight down in it. Is there standing water inside the inspection port? And so that's going to indicate, of course, how well the percolation is going in there. Now they have, if there's any standing water at all, yes, well then, we call in a service tech. I don't see that that's necessarily a failed system just because there is some standing water. And then, of course, be sure to replace your inspection port caps. Okay, now we're going to move and look at the distribution box, also known as a D-box. So to the extent you can, you want access to that D-box. And so here, ideally, you can just remove the D-box. That's your typical one. So and evidently in Washington, you can remove the D-box access riser lid and remove the D-box lid. And then you're looking in the D-box to see if it's free of solid waste or clogs, because you can't get an even split on the flow if you got solids plugging up one of your laterals, so the other two laterals are overloaded and this one is starved. So there's definite merit if you can look at the D-box to do that. Also, is a D-box free from cracks and leaks? Does the effluent appear to be flowing evenly into all the drain pipes? So as you can see, there's a lot of value in being able to inspect and look at the D-box if you can get to it. Gently replace the D-box lid, ensuring you don't pinch fingers or disturb the D-box. Then you'll replace and secure the riser lid. And the recommendation, if your D-box does not have an access riser, have one professionally installed, and some systems do not have a D-box. So now we got to go through and do the cleanup. So you're going to fill a 5-gallon bucket with 10 inches of water and 2 inches of bleach to make a 5-to-1 cleaning solution. Then you're going to wash all tools and tarp with bleach solution. Then you're going to gently pour the soil solution into the inlet side of the septic tank. I might mention that any residual bleach that's still active will quickly be oxidized by the solids in the septic tank. So it really shouldn't affect adversely your treatment process in the septic tank. Replace and secure the riser lids, discard rags and plastic trash bags, discard gloves and plastic trash bags. Wash clothes with bleach. Just watch how much you put in there, or you might remove the coloring in your clothes. Then wash yourself with plenty of soap and hot water. Don't wash yourself with bleach. Now, we go to the service provider. So, there needs to be a coordination for getting service provider help and what they're supposed to be doing. They're going to inspect for leaks. They, if need be, can measure the depth of scum and sludge layers in the septic tank. That's if needed. The homeowner can do that. Then the system owner, if they've delegated this out to the service provider, then they need to make sure they keep maintenance records. what all was done on the system, depth of scum, depth of sludge, when it was measured, and so on. And of course, you're going to record, like I said, the measurements of scum and sludge layers along with the date of measurement. Now, let's look at this issue of scum and sludge measurement. I have three different options here: EPA, Washington State Department of Health, and ADEQ. EPA recommends this. The bottom of the scum layer should be no closer than 6 inches to that outlet T, sanitary T. The top of the sludge layer should be no closer than 12 inches to the entrance of the outlet T. The total of the scum and sludge layers should be no more than 25% of the total liquid depth. Now, I've got a little schematic here. We'll look at that besides just looking at this text. And here, you know, in Arizona, it's happens to be 42 inches, so 42 inches times 25%, 10.5 inches. So that's the EPA's recommendation. The Washington Department of Health, their standard is maximum scum depth of 6 inches. The maximum sludge depth of 12 inches. A combined maximum scum depth and sludge depth of 18 inches. ADEQ, when you look at A314, I had to do some pretty good math, but I actually came up with a maximum scum depth of 6 inches, a maximum sludge depth of 18 inches, and there's my schematic. You look at the different values and references in A314, and you can do some calculations backwards and come up with this. So our scum here, max of 6 inch, and the inlet T is supposed to be 10 inches below the water surface, inlet and outlet. So you get your 6 inches there. Then maximum sludge depth of 18 inches. And that'll put you where you don't have any, you're not any closer than 12 inches to the inlet of the sanitary T there. Now let's talk about septic tank pumping frequency. First, requirements that all septic tanks must be pumped every 2, 3, or even 5 years are simply unsupported by the scientific evidence. I know that's common terms. I will qualify this to say that if you got an undersized septic tank or one of the trash tanks in some of these secondary treatment facilities, you are going to have to pump it very frequently, and it may not even be 2 years. You may be pumping it every year if you got a real small trash tank on some of these. I don't call that a septic tank, though. A true septic tank that's in front of whatever secondary treatment device should be properly sized. But if we have only a septic tank with proper sizing of 2.1 days detention time, you can pay attention in particular what I'm saying. The microbial activity that affects optimal decomposition takes up to 3 years to develop fully. So if you pump it every 2 or 3 years, you're never even really getting optimal microbial development. You're cutting it short. In 5 years, considerably less than half of most tank scum and sludge capacity has been reached. That's by Bounds in 1988 publication. Pump out should be scheduled based on inspections and monitoring records. Measure your scum, measure your sludge. If it exceeds those levels, as we referenced in these earlier slides, pump. That's the best way of doing it instead of trying to go with 2 or 3, pump it every 2 or 3 years. So, further thoughts on septic tank pumping frequency. Design manuals may encourage frequent pump outs. Now, this could be a precautionary measure when an inspection program is not in effect, which we're advocating an inspection program. Longer intervals are usually justified, particularly if an effluent screening device is in place. Adequately sized tanks need less frequent pump outs. Septic tanks are an effective permanent solution to lack of a public sewer. But they deserve the same scientific consideration as other treatment systems. Now let's think about the effect of using water efficiently. All water used by the occupants of a building, excluding landscape irrigation, goes down the sewer drain to the septic system. Efficient water use improves the operation of the septic system. Now, faucet aerators, high efficiency shower heads and flow restrictors reduce the volume of wastewater being discharged to the septic system. So your hydraulic loading is decreased. So that means you've got a longer detention time. So hopefully the solids can settle out better. Now, a toilet now typically uses 25 to 30% of household water use. That's why there's been a big push on these low flow toilets. Older homes have toilets with 3.5 to 5 gallon reservoirs. Newer high efficiency toilets use 1.6 gallons of water or less per flush. Washing machines. Washers with the Energy Star label use 35% less energy and 50% less water than standard models. Washing small loads of laundry on the large load cycle wastes water and energy. So by selecting the proper load size, you will reduce water waste. If you're unable to select a load size, run only full loads of laundry. Spread washing machine use throughout the week. That's a preferred way and has less impact on your septic system. Doing all household laundry in one day can harm your septic system because you're doing, needless to say, a massive amount of hydraulic loading on your tank and disposal field. And it's not going to allow your septic tank enough time to treat waste and can flood your drain field. So you're reducing the detention time potentially in your septic tank, as well as loading very heavily your disposal field. Now let's think about disposal of waste. Everything that goes down your drain is up in your septic system and affects how well it works. So the U.S. government has some nice little things, the Septic Smart things. Do your part, be septic smart. So this home has a septic system to prevent plumbing problems, keep hygiene products, hair, wipes, medicine, trash, and other products out of the toilet and drain. Your toilet is not a garbage disposal. Toilets are not trash cans. Don't overload the commode. Don't flush all these things. Don't put other things like cigarette butts, cat litter, paper towels, pharmaceuticals, non-degradable products down the toilet. Dispose of these in a trash can. Now, let's think about drain field maintenance. So here is what I call a compact lot septic system setup. So we see the disposal field is exposed here, looks like chambers. So remove contaminants from the liquid that emerges from your septic tank. So that's what we're doing by getting rid of some of this other stuff. Do not park or drive on your drain field. And that's what's kind of dangerous about having your disposal field in the front yard, is that somewhere along the line people said there's not enough room for off-street parking. Let's just convert this all into a parking area and park in our front yard. Planting. Plant trees the appropriate distance from your drain field to keep roots from growing into your septic system. So this will be not be a good location for planting a nice tree or something that's going to put the root system heavily down into your disposal field. Placing. Keep roof drains, sump pumps, and other rainwater drainage products away from your drain field area. This reminds me of a property that I inspected in the Nogales area. This was like, picture this is the backyard, and all the roof water runoff went right straight off and flowed right into their disposal field. And I got out on the side and says, sorry folks, this ain't gonna work. Put yourself a roof gutter over here and then drain your stormwater off over here, not onto your disposal field. So excess water slows down or stops the wastewater treatment and disposal practices. So you want to keep that stormwater off your drain field. Now, what are some questions about caring for a septic system? Should I be careful of what I pour down the drain? The answer is yes. Many materials do not easily decompose. Can be harmful to the healthy bacteria that breaks down organic matter. Harmful chemicals put down your drain can impact drinking water supplies in the environment if your effluent reaches groundwater in particular. Does using a garbage disposal unit impact my system? Yes. Food waste is slowly digested by healthy bacteria in your system and can accumulate as scum and sludge. So, if you want to pump out on a frequent basis, then by all means, use a garbage grinder and dispose of the waste into your system, and you can pay somebody a lot of money to pump it out. If the tank is filled with solids from the disposal, the additional wastewater entering the treatment tank can push solids in the drain field and cause pipes to clog. It will increase the thickness of the biomat and lower the soil absorption rate. If you must use a garbage disposal, your tank will need to be pumped more frequently, as I stated earlier. What can I flush down the toilet? Human waste, toilet paper. That's it. They're not trash cans. Should I avoid driving or building on my drain field? Yes. Most systems constructed in open lawn areas are not designed for vehicle weight. As we can see in this truck, and it looks like he might be stuck in his spinning, digging a hole into his disposal field. Vehicles compact the soil and damage the pipes. Concrete and asphalt reduce evaporation of the effluent and reduce the supply of oxygen to the soil. Oxygen is critical to the aerobic bacteria. And that aerobic bacteria help break down the biomat buildup that the anaerobic bacteria are busy building on the inside of your disposal trenches and beds and so on. Now, let's consider some questions about caring for a septic system. Follow Septic Sam's landscaping do's and don'ts. Don't plant a vegetable garden on or near the drain field. Don't put plastic sheets, bark, gravel, or other fill over the drain field. Don't reshape or fill the ground surface over the drain field and reserve area. However, just adding topsoil is generally okay if it isn't more than a couple of inches. Don't make ponds on or near the septic system and the reserve area. Do plant grass or keep existing native vegetation. These are the best covers for your drain field. Direct all surface drainage away from the septic system. That's a really good point. Use shallow-rooted plants, see plant list above. Tree and shrub roots can grow into the drain lines, clogging and breaking them. Avoid water-loving plants and trees. Make sure the tank lid is secure. And this whole idea of filling over the ground surface of the drain field can be really a bad idea. Okay, let's look at lessons from the fields and some pictures. So needless to say, this is a septic tank. Looks like the top is caved in, and it looks like there's a lot of solids in the tank. I don't know whether that's soil or something else, but this is like a leader picture to show you what could follow. Okay, now we're looking at a disposal field. We can see the 4 inspection pipes here. And it looks like there's a little effluent. It looks like it's either coming from this direction flowing toward us or starting here and flowing away. And we can see some tracks, vehicle tracks, tire tracks, something. So a big question is, why is the failure limited to only one trench? Notice nothing you've got 4 trenches, but only one is showing effluent going here. So looking at the ground surface, I can say there's something funny happening here. Now, some possibilities. There is a pluggage, and the other 3 lines are plugged, and all the effluent is going to this one line, and it's overloading it. It could be that. Another thing is, since there's vehicular traffic here, maybe there is some damage been done to the piping or distribution box or whatever, somehow that's allowing effluent to get out here and pond. But this is a symptom. This is not necessarily the problem. You're going to look for a root problem. This is what I call a surface problem. That's a warning to me to dig a little deeper. Okay. Now here's another interesting one. A couple of questions. Why is the grass not growing over the disposal area? Notice we got this beautiful grass growing really well here, all over there, but it's like a barren landscape right here, and it looks like something was trying to grow here and it's all dying. Because I'll tell you, look at that, we got plenty of water. Why isn't this growing lush green grass? There's a problem here. And now, how long has this disposal field failure been ignored? Obviously, it's being ignored. If you look closely, it appears there's white, so areas of white here. My guess is that we have a person that is concerned about effluent loaded with bacteria and virus, and they sprinkled some calcium hypochlorite to try to sanitize this area some. They didn't correct the root problem. You shouldn't have this growing on the surface. They've just been sprinkling the calcium hypochlorite, which is also a big deterrent for grass growth. So my guess it's been a while, and the calcium hypochlorite is probably the reason why there's no grass growing there. Now, my question is why do you need an influent baffle? We see here the influent pipe flowing in, and this is one of the older tanks where they have like a cast-in-place type baffle. There's nothing here now. Well, obviously some corrosion took place, and now they've actually removed the cover, obviously, and it's pumped down. But solids could back up and go into your influent pipe. That's one reason, of course, why you need an influent baffle there. Keep that out. All right, why do you need an effluent baffle? So here's a nice picture of a concrete effluent baffle that's being corroded and is breaking down. And so, of course, you have the baffle to keep solids out of your disposal field. So there's a way of actually doing some repair work and putting in a baffle in this after you clean all the deteriorated concrete off. Now, this is another reason for why you definitely want to pump down the tank, is examine the sidewalls, the bottom of the tank. We don't have everything out, so you can't see the bottom yet. Now, my question is, what is significant about this cracked wall? When I look at this, it almost looks like this wall is bulging a little bit inward, but you've got some major cracks here. Now, there is a soil that when you let water get to it, it expands, and you can have what's known as an expansive clay present. So if we have water, we have a tank that's cracked, started leaking water, getting to the clay expands, opens this up. This crack is opened up pretty good. So that may be some of it. Needless to say, if it was clay, maybe it's sealing this. If it's not clay, and there's some other reason, such as a saturated soil and a heavy truck, your live load is going to be transferred down and blow this tank in some too. So there could be more than one cause for this tank to be like what it looks like to be bulging slightly inside. Now, this is a effluent filter on the septic tank. So what does the condition of this effluent filter indicate? Well, a few things I think we can surmise here, possibly. Number one, it's been a long time since the effluent filter has been cleaned or checked. If somebody says, no, I just cleaned this 6 months ago, okay, then I would say we got some pretty heavy organic loading, hydraulic loading going on, maybe an undersized septic tank to have this kind of solids build up in a short period of time. But as I said before, always keep in mind you want to be looking for a root cause. You don't want to be just looking at a surface problem. Oh, I just need to clean this. Yes, you need to clean it, but when was the last time you cleaned it? And start thinking about, is there another problem? And this is a warning sign that there's another problem here that I need to address. Now, I thought this is a pretty good one. What is significant about this root intrusion? And right now, we got a root that's like it's coming out of the pipe. And given the fact that it's very large here, and then it kind of gets smaller and maybe curls around, I'm thinking this is the influent pipe. This one here is coming in, it looks like, through the edge of the crack between the top of the septic tank top and the sidewalls of the septic tank. So what is significant about this intrusion? Well, my guess right now is this pipe is damaged over here, and we got some plant, tree, or whatever that's able to get into this pipe because these roots seek water. And so it found it and went right down in the pipe, and then it made it into the tank. There's moisture coming out. Roots actually appear to be able to sense water vapor, and they will try to go back to its source, and they'll send out roots and then expand them. So there probably needs to be some treatment around the outside of this tank to inhibit root growth. Okay, so what is significant about the location of the roots in this photograph? Well, it looks like there's lots of roots and underneath the tank. We see some evidence of roots right up here on the edge where they pull the lid off. So it looks like there's a lot of plants and stuff that's putting out roots, and they're going for the septic tank. And so we need some type of treatment around the edge to stop the roots from penetrating it. Okay, then what is the condition of this septic tank? I would say it's rather poor right now. This looks like soil here. So maybe the septic tank is completely deteriorated away, and this is sections of the tank that's fallen in. I think this might be a pipe right here. It's hard to say. These are the ends of roots coming in. I would say very clearly the septic tank has failed. Now, why is this inlet baffle encased with solids? So if we have the outlet not able to carry the flow away, then there's going to be a backwater effect. The scum would rise up and over the top. Another thing is the scum layer just built up and it wasn't ever pumped. My father-in-law was very proud of the fact it'd been like 20 years and he's never pumped a septic tank. But maybe somebody had that same idea here, that they could go 20 years and never worry about their septic tank, only they had a problem. Why is this baffle encased with solids? Same thing. I'm not sure whether this is inlet or outlet, but everything got too high, especially if there's any partial pluggage or major pluggage on the outlet of the septic tank. Now, why is a hole in the side of the riser a problem? This happens to be actually a facility I inspected in Santa Cruz County. The maintenance guy liked to use a weed whacker. I don't know if has weed whacker damaged this, but that basically allowed mice, snakes, litter from his weed whacking and other stuff to get inside this. This happens to be a recirculating sand filter. So that's not a good thing. This is the same facility. It's a recirculating sand filter. This is the sand bed here. This is a rotating valve that shifts every time the system is pressurized to distribute effluent in the gravel bed. This thing like ratchets up and routes it through one flow zone after another, and these are the shutoff valves for the different flow zones. But my question when I was doing an inspection on this, and you notice though the guy was very nice. He weed whacked and cut everything down so you didn't have to worry about getting bit by a snake or anything. So why is there grass over part of the sand filter area? So notice there's grass here, but there's no grass out here. Why is that? What we found out is that one of the zones, the pipe and connecting pipe to the zone, was broken. So when this rotating valve got around to supplying effluent, it went ahead and discharged the effluent through this broken part, flooded this whole area, and of course the grass went where the water was, and it proceeded to grow. And there was some water and some of this just in the natural course, so it actually just kind of like encouraged the growth to move toward the east into the disposal area. Okay, this is a seepage pit, and this is the same facility. This recirculating sand filter disposed their effluent to seepage pits. These seepage pits are about 100 feet deep. Groundwater is about 200 feet below the ground surface. And when I went out and I inspected it, I noticed, this looks like the whole ground is settling around this, going down. Why is this settling? And you might ask, well, first, where is the soil going? Well, this is a seepage pit that is filled with gravel. Gravel has voids. So when surface water is coming in contact here, and it probably had a small depression. So now then the surface water is percolating down through this. The soil must be permeable enough. And now it's carrying the soil down into the gravel voids and starting to progressively plug the seepage pit. And so I pointed out to the people they needed to stop this. They can't let this go on. You're going to have a failure in your seepage pit. Let me just say this about this. Let me go back to that slide again. Another comment. They had the good thing was they had some actually really good shallow rooted vegetation here. The bad thing was they had a lot of buildings off this side where we had some good drainage coming this way. I suggested they consider building a diversion barrier running in front of all of their seepage pits to divert stormwater away from this area. I suggested they also fill this area in, mound it slightly so that stormwater would run off from it and not pond on it. So I gave them some further advice how to correct the problem and avoid future problems. Okay, at the same facility, needless to say, I had lots of problems that I uncovered. This is what's known as an indoor electrical coupling. This is not an outdoor electrical coupling. It's not outdoor type. So water was, this is caulked to stop water from going through this joint and getting into the control panel and messing things up. Notice there's no caulking around this, so water could still go underneath and get in here. You know, that's when it was being constructed, they should have used an exterior coupling that was watertight. All right, so now same facility, our recirculating sand filter. How did this grass get into this effluent recirculation tank? I wonder if it was through that broken riser section when they're weed whacking. Some of the grass blown up into the air, then got into here. And it looks like there's some scum and other stuff that hasn't been removed in a while. So it would be a part of proper maintenance would be to get rid of this. What does this floating scum layer indicate? It's a lack of monitoring and maintenance here, and things will still grow even in effluent. What are the negatives associated with this type of seepage pit? So this is a hollow seepage pit. It's not filled with gravel. And so the big thing, it looks like there's a lot of roots. And so we have a potential for a lot of root intrusion. It looks like there's a little more chance for soil also to make it in because there's a lot of holes. If we, at least in the upper portions, if we had some heavy rain, soil saturated with rain, and water and so on, you might be able to see some more movement of water in here. Of course, anything that comes in is going to fill up the bottom of this, and it's going to reduce your percolating ability. Okay, this is another seepage pit. So what is the condition of this seepage pit? The good thing is it doesn't look like the side walls are caving in, but it does look like with the material that was used here, your percolation is going through the side walls. So it looks like we got some good buildup of biomat and stuff on the sidewalls of the seepage pit. To have a better understanding, it would be interesting to know what the depth of water is below this, and are they experiencing any problems with high water in the seepage pit? Obviously, it's probably pumps, so it might have been why they're able to examine this and go down a ways, as they just pumped it because there was problems associated with it. Here's another version. What's dangerous about this seepage pit? First off the bat, it looks like it's structurally unstable. So anybody that walks above this might potentially end up being ground collapsing and carrying them down in it with being buried alive. But you also have some pretty big openings, which will allow soil and other debris to fall into the bottom of the pit. Notice this. My question is, why is one section of this grass greener than the rest? So it's nice and green right here, relatively dry. And in fact, it looks like this is maybe vehicles drive over it. Vehicles could very easily drive over this. I believe this is where the disposal field is located. In fact, I think that little zone of green is one trench. That little zone of green is another trench. And the little green over here, I don't know if this is starter one or just a carryover from the moisture in these two trenches where they're kind of going side to side. All right, what is the problem with a distribution box being at least 6 feet in the ground? This is a facility I inspected out in Cochise County. They had some of the deepest buried septic tanks I've ever encountered. And I noticed very high watermarks on the risers. And I said, you guys got a problem here. The effluent's not getting out of this septic tank. And they basically went out and found their problem. It was right in front of this distribution box. But by virtue of it being 6 feet in the ground, it's very difficult to get to. They had to get a backhoe in here and really do some good excavation to get down to it. I found that the pipe, looks like when it was originally installed, the PVC pipe connecting this was like mostly crushed. There was a little bit of effluent that was getting through. This is some of that, and I'll refrain from saying it. There's some question about, is this the legitimate trench width? What does a narrow gravel trench indicate? Maybe the contractor didn't want to spend as much money on gravel and put a narrow trench in, because this is the same trench. And maybe their earlier construction work with a crushed pipe and super deep septic tanks or whatever has something to do with that. Okay, now we see here inside of a septic tank, how effective is this coating? I tell you, from my experience, this is actually looking pretty good. If we had a coating failure, I would expect to see bubbles and corrosion. And actually, I'm not seeing it, so I'm actually pretty impressed that this septic tank coating is actually amazingly holding up. What is the purpose of this short concrete wall? This is another facility I inspected, and this was a low area, and so the drainage comes toward happens to be the western end of this little block enclosure concrete wall. So this was basically a diversion. So the stormwater coming this way is diverted around it, so it doesn't tend to just pond. And this is where, this happens to be a step system, so there's pumps below there. And here is a septic tank. What did the designer and contractors for this new garage miss? Well, they missed the fact that they just built this new garage right over the septic tank. And they discovered it right there, which wasn't real good either. Now here is what happened to this plastic septic tank. And you can see the side walls of the tank is like protruding in, and I use plastic in quotes. I don't know whether it was polyethylene, actual PVC, polypropylene, or whatever. But if you got the soil out here saturated and you drove a large vehicle over it, that live load is going to be transferred to the side of this tank and just collapse it. So that may have been part of it. I don't know, this picture doesn't give me enough picture of how far down this is, but if everything gets really wet and saturated, your dead loads could be pretty significant. If the bedding of this tank was improper, the side loads could move in, because a flexible tank type, a flexible tank needs uniform support along the side or it will collapse. So now we come to acknowledgements. I just acknowledged the Washington State Department of Health, Department of Ecology, State of Washington, Environmental Protection Agency, T.R. Bounds, professional engineer, and his publication 1994. And thank photo credits for Doug Dispro and Don Law. Now let's see if we can look at any questions that we have here.
Ray, you're sharing your IMs, so you want to stop sharing your screen?
Yes, just a minute. Let me figure out how to do that. All right, there we go.
Okay.
That'll
And
be,
if you want to turn on your camera.
okay, camera's on.
And I don't know if you've pulled up the question panel, but the first question was, are the PhDs available?
Are the THDs, the slides?
No, are you getting credit from registered sanitarians for this session?
Yes, we are. 1.5 hours.
And they just need to save the agenda to prove that they participated?
Yes, we've already run it through the Sanitarian Council. and all they have to do is just make a copy of the agenda, and it's already recognized and approved for the sanitarians. If you're like an Arizona operator, just take a copy of the agenda and use that, and you'll get credit for that. For whatever time. At this point, it looks like we're going to be about an hour and a half.
Okay, so question, is bleach harmful to your septic tank?
In small quantities, it's not. Large quantities, it would. It's an oxidizer, and it will kill bacteria, but it'll also react to carbon. And that's why I say that small cleaning solution that has a mild chlorine solution there, it will easily be oxidized and consumed from the carbon in the septic tank. But if somebody were to be putting a lot of bleach, then that could be more harmful. Just like if somebody was taking like a medication that had a very high bacterial, was a very strong antibiotic or chemotherapy, those kind of things could really start affecting the septic tank. When you remove the cover, it should just be an earthy odor, kind of a brown, dark earth brown or whatever. If you're smelling a really bad odor and it's like gray color, you got some problems.
Okay. What about bleach in the leach line?
Wow. I would not put bleach in a leach line. You're messing with the bacteria out there, and so I would not recommend putting bleach in leach lines, personally.
Okay, we had a question as to whether or not this presentation will be made available. Yes, it will be. We typically post them on the website, but since our website's going through some major maintenance, what we'll do is we will email it to those who participated in this session directly. And then once the website work is done, we'll be able to post it. But in the meantime, we'll go ahead and just email it out to you. You got a question from Dave Ray.
Okay.
How do you remove a grease load infiltration from the leach line?
How do you remove a grease load infiltration from the leach line? Actually, there is a treatment process that will do it, and I can't state that here because I don't want to promote any one given product. But there are treatment processes where bacteria that are real good at reducing solids and grease that could go out into your disposal field and works pretty good on that. Now, there may be other products. Bottom line is that in your septic tank, you got one group of bacteria doing their job. On a disposal field, you got some bacteria doing their job. And then they're kept in balance by aerobic bacteria on the other side of that biomat. But then there's some other bacteria that are specialized that you might be able to go down to add that into your disposal field. But it looks like Dave has another question.
Yeah, bugs in a jug.
I've never heard of that one. I'm not going to rule it out. That may be another approach for trying to get the bacteria to be able to go in there and do the cleaning job. And of course, it's the fact that you've got grease in your disposal field or dispersal field is a bad sign. That means something went wrong in the septic tank and in your whole treatment process to even get to that point. So
Yeah.
now you're playing cleanup.
Yeah, so Dave was saying it was a euphemism. So Dave was being funny, as he always is. Thank you, Dave. We appreciate the humor.
I thought it was a real container with some special bugs we could flush down. Dave needs to come up with that solution.
There you go, a new patent for a new product.
That's correct. All right, any other questions? Okay, thank you for attending. I hope you learned something new, and I'm glad that we could make it through this just fine. Thank you.